Hello and welcome. This is a presentation of the Oracle OpenWorld Scheduler application built by Jonathan Eagers as project manager, Matt Swan as lead developer, and myself, Cass Kettner, as database administrator and subject matter expert. The Oracle OpenWorld Scheduler application is an intelligent scheduling tool designed to streamline the process of registering for sessions at the annual Oracle OpenWorld conference. The conference sessions are organized into 10 main streams. Within those streams, there are 72 more narrowly defined tracks, and each of those tracks contains from 3 to 247 sessions. For instance, the video sessions stream contains 6 tracks, one of which is Oracle developed keynotes. Within the Oracle developed keynotes track, there are 3 different keynote sessions. Sessions range in length from 45 minutes to 4 hours. However, most are 60 to 90 minutes. Throughout the 5 days of the conference, there are 130 different times when sessions begin. With 199 different conference rooms spread across 10 venues, it can be very difficult to derive a sensible schedule manually. The bulk of conference sessions are located in the Moscone complex, the red buildings, and the neighboring Marriott Marquis. However, the Hilton Union Square to the north also hosts a large number of sessions. The 9 venues in the Moscone Center area are less than a 2-minute walk from each other, and the question and answer portion that comes at the end of each conference session provides enough time to duck out early and get to a back-to-back session in another nearby venue. Alternatively, you could stay to the end and just accept that you'll be a few minutes late to your next session and probably miss the small talk and introductions. Most experienced presenters wait until about 5 minutes after the official start time to begin. Getting from the Moscone Center area and neighboring venues to the Hilton requires a 15-minute commute, and it also requires a 15-minute commute to get from the Hilton to any of the other venues. Oracle supplies a fleet of about 40 buses that depart from each venue in 5 to 10-minute intervals. The main goal of the Oracle OpenWorld Scheduler application is to facilitate attendees in quickly scheduling the greatest number of desired sessions they can possibly attend during the 5 days of the conference. The application is intelligent because it checks for and resolves time and location conflicts by minimizing session overlap and shuttle commutes. It maximizes value for the attendee by minimizing gaps between sessions. Additionally, it resolves prerequisite conflicts by ensuring that an attendee is registered for Part A of a presentation if the attendee attempts to register for Part B, and vice versa. The Oracle OpenWorld Scheduler database required 16 tables to support the desired application functionality. The C Sessions Instances table allows the association of a single conference session with multiple start times in the case that a particular conference session is offered multiple times throughout the week, which many are. The Oracle OpenWorld Scheduler database, like the actual Oracle OpenWorld Conference of 2010, has 10 streams and 72 tracks. Our proof of concept dataset includes 259 unique conference sessions and a total of 275 conference session instances. The 275 conference sessions span all 10 streams and 72 tracks.
This part of the presentation is a demonstration of the Oracle OpenWorld Scheduler application. A user of the application would begin by registering. The application employs a typical registration process where the user enters their name, email, and password and submits this information to the application. The user then receives an email with a confirmation link. After clicking that link, the user's account is activated and they can log into the application. After logging in, the user will see the My Schedule page of the application. For a new user, this page would have no sessions scheduled. Scheduling sessions is easy. To view a list of available sessions, the user clicks Browse. They see all available sessions in alphabetical order. They can narrow those sessions by clicking on a stream. Within each stream are tracks. To change a track, they simply deselect their current track. To change streams, they do the same. To schedule a session, they click on the session that they want to learn more about. They can read the description, see what times and days the session is available, and add it to their schedule. To schedule another session, the user simply clicks Browse. The application takes them back to the stream and track that they were previously viewing. They can easily change streams, choose a new stream, a new track, and a new session. And they can schedule that session. If they attempt to schedule a session that conflicts with a conference session already in their schedule, they will receive a message that there is a time-based conflict. It will show them which session is in conflict. If there are alternatives, it will show them an alternative time that they can schedule. If the session they are trying to schedule has a prerequisite, the application will also show them part-based conflicts, letting them know which sessions are prerequisites for the session that they are attempting to schedule, and it will allow them to schedule those prerequisite sessions. So for this example, we can schedule session 1A. We can then go back to the previous view of the available sessions. We can click 1B, and we know that this session from 1 to 5 is in conflict on Sunday, so we will choose the Wednesday session to add to our schedule. Besides time-based and part-based conflicts, the application also resolves location-based conflicts. For this demonstration, we've scheduled the Java session 1A and 1B for Sunday. We'll browse for another session, we'll select this billiards competition, and we'll attempt to add it to the schedule. The application tells us that there is a location-based conflict between the billiards session we are attempting to schedule and this Java session 1B already in our schedule. The two sessions are occurring at venues that require 15 minutes of travel time, but the time between the sessions is 0 minutes. It gives us the location-based alternative of the session 1B happening on Wednesday, which will resolve the conflict. But the application also allows us to schedule the session anyway, because a user may want to leave a session early or arrive at a session late. This concludes the demonstration of the Oracle OpenWorld Scheduler.
Our biggest challenge in coordinating code was keeping both the application logic and the database on the same page. Our project used the Agile process, and the coding of the application during each iteration led to changes in requirements that led to changes in the database. Despite each of us being US-based, when the application required changes to the database, we were not always available at that particular time, so we could come together and decide on an appropriate solution. The result was that certain changes were made in the database on the fly, and this led to a certain balancing act as the database team ironed out the changes made by the application team, and the application team ironed out the changes made by the database team, and so on and so forth. An example of this includes the prerequisites table. The application team needed a way to connect sessions with their prerequisites. Their answer was to create the prereqs table to hold pairs of session IDs, one of which was the prerequisite. It was important for them to share this with the rest of the team because the table was not created with constraints in mind. The database team then had to go back and ensure that the proper constraints were in place to ensure the data was being handled with care. Another example is the All Presenters table. Originally, the application team created both a first and a last name field and split the names. Once the group had a chance to review, it was decided that a single name field would suffice, and the database team was tasked with this correction. It wasn't always the application team causing trouble. At times, the database team might have changed or added fields or created constraints that caused certain application logic to fail, and the application team needed to respond by updating the queries in the application logic to conform to the new design. All in all, the group came together well to provide a little rope to each other so that each team could work when they were available and accomplish their task with regards to each week's iteration. As each iteration came and went, the team smoothed out both the database and the application logic, and these issues came less and less frequently. Two examples of the most challenging code include recognizing and communicating conflicts and providing and handling alternatives. The application tests any session you try to schedule against your current schedule to determine if there are conflicts, and then it displays those conflicts to you. Conflicts can be time-based, where two overlap, location-based, where the time between the two is less than the estimated commute time, or part-based, where the user is scheduling a part 2 after a part 1 or vice versa. As an example, let's take a look at location-based conflicts. Here, it isn't enough to simply compare times. We need to additionally get each session's venue and then find the estimated commute time between the two venues. If the commute time is greater than the time between the two sessions, the user is shown the conflict. Alternatives were our second big challenge. Let's look at an example of part-based alternatives, since suggesting alternatives for part-based conflicts was much more involved than both time and location-based alternatives. For example, let's say a user schedules part 1 of a session on Wednesday. Here that session is Java User Group Community, Breakout Session 1A. Its follow-up session is Breakout Session 1B. Now he schedules Breakout Session 1B for Sunday. This clearly creates a conflict. The user needs to schedule both sessions in the correct order, so when the application is looking for these alternatives, it isn't simply looking for any other occurrence of part 1. We needed to tell it to look specifically for an occurrence of part 1 that occurs prior to the session of part 2 that the user is currently trying to schedule. In this case, we can see that Java User Group Community, Breakout Session 1A, is also available on Sunday at a time that would coincide with the user's attempt to schedule Breakout Session 1B on Sunday as well. Given these circumstances, the reschedule session option will allow the user to reschedule Breakout Session 1A from Wednesday to Sunday, at which time he can then reattempt to schedule Breakout Session 1B on Sunday. Now, Breakout Session 1B on Sunday may be scheduled without conflict. Hopefully you can see how challenging the coding of these functions became. One of the more important aspects of coding these functions was trying to keep a single query to get the information we needed about the relevant sessions. To do this, we needed to code some complex queries, including subqueries.